Greetings everyone. My name is Alexander and I'm a professor at the Institute of Engineering of Porto in Portugal. This talk is about an approach to add software product line engineering support to low-code application platforms. This work is a part of a research project funded by the European Union. This is the outline of my talk. I will start by discussing the context, low-code and no-code application platforms. Then I will present the motivation for this work, challenges and contributions. After that, I will present details about the approach to add software product line engineering to low-code application platforms that is based on domain-specific languages. And finally, I will address the lessons learned from a case study and conclude with the talk with some perspectives on future work. No-code and low-code application platforms are tools that can be used to create applications, particularly web or mobile applications, almost without requiring conventional programming languages. With these tools, the user essentially uses visual constructs to model the applications. However, being very recent, these platforms also have yet some ground to evolve, particularly for some specific aspects in software engineering. In this work, our focus is the product line engineering aspect, as we will see next. So here we visually compare the software product line engineering process in the left and the low-code application development process in the right. We can see that they both support application engineering, but the domain engineering component of the software product line is missing in the low-code application platform development. In particular, two major components are missing: domain models and variability models that are essential for software product line engineering. Here I address the challenge we faced and the corresponding contributions of this work. Regarding the proprietary approach of the majority of the low-code application platforms, we complement it by adopting a model-driven engineering approach using open standards. The majority of low-code application platforms are closed source, so we do not have access to the source code. Our approach is non-intrusive with regards to the platforms. It only requires the presence of an import and export mechanism for models of the platform. One of the biggest challenge was to not have access to the metamodels of the platforms. To tackle this, the approach proposed the deduction of the metamodels. These platforms use data-oriented formats in their export and export of models. We provide a domain-specific language with a rich environment for the addition of the domain models. Also, low-code application platforms do not support variability management. In this regard, we also provide a domain-specific language for variability management that is integrated with the domain-specific language for the domain models. In this diagram, we see how the approach provides the domain engineering missing layer. The solution is based on an integrated development environment and on domain-specific language, a set of domain-specific languages. The solution was built with Eclipse, the Eclipse modeling framework, the Xtext language workbench, and the Atlas transformation language. Let's just briefly review the process. So we only use model import and export mechanism of the low-code application platform to connect between the the IDE and the low-code application platform. Domain models are exported from the low-code application platform and converted into a low-code domain-specific language that is used inside the integrated development environment. The product line features are modeled with a variability domain-specific language that is integrated with the low-code DSL. Application configurations use also the variability DSL. These configurations are used to generate the models of the applications of the product line. These models are then imported into the low-code application platform using the same import and export mechanism. We'll now present some details of the approach, starting with the variability domain-specific language. Regarding variability modeling, the approach uses a specific metamodel for each software product line. This results in variability domain-specific languages with user-friendly syntaxes, using syntax that is close to the domain language. Also, since the variability DSL uses the same language workbench as the low-code DSL, their integration is automatic. One of the main challenges was building the low-code domain-specific language, because low-code application platforms usually do not provide access to their metamodel. Here, the approach was to deduce the metamodel from the exported models of the platform. The process, which is detailed in the paper, allows for the partial automatic deduction of the metamodel in a first step. This step includes in the metamodel the reference to the variability metamodel also, so that the resulting models can have variability annotations. To complete the metamodel with the missing information, a second step is required, in which the metamodel is complemented with the missing information using a refining model transformation that leaves intact the elements not affected by the transformation. The metamodel that results from the previous process is then used as an input to the Xtext wizard to generate the supporting artifacts for the domain-specific language, particularly the grammar file. In this phase, some customizations may be required, for instance, for customizing the terminal rules of the grammar, for adjusting the order of parsing, or to customize the support for the variability annotations in the domain-specific language. With the low-code and variability domain-specific languages in place, the missing component is the configuration process. This process can be implemented as a refining transformation that takes as input the model of the domain and the configuration for a specific application, and it will generate a model for that application. This model can then be imported again into the low-code application platform by the same importing-exporting mechanism. The approach was applied and evaluated in a case study for a software product line for order management. The low-code platform used was OMNIA. In the table, we see some measures about the case study. The total duration was about 2 months. A significant part of the duration of the project was related to tasks performed by researchers. Some of these tasks are performed once for each platform and others once for each product line. The model of the order management domain was produced by a team of consultants from the company that builds the low-code application platform. The application generation required just a few lines of variability DSL code that was entered by an end user of the low-code application platform. Here are some notes about what we have learned from this experience. The non-intrusive way to integrate with low-code platforms maximize the adoption of the approach. However, it has also some limitations. It requires integrating always the totality of the model. A more granular integration mechanism, if available, such as using a REST API, could result in a more reactive modeling experience. It is arguable that the approach is adequate for citizen developers. The response was very positive with the users in the case study, but we would categorize them as low-code application platform developers, not citizen developers. Regarding the replication of the approach, it requires a strong expertise with model-driven engineering and some MDE tools. Further automation is required to minimize this limitation. To summarize, we presented a non-intrusive, a partially automated approach for supporting software product line engineering in low-code application platforms. Users were able to implement a software product line for a scenario that before was only roughly addressed by elementary reuse mechanisms. In the near future, we need to validate the approach with more case studies and with more low-code application platforms. We plan on improving the Metamodel deduction mechanism and the generation of the DSL grammar. We also plan on evaluate the integration of generic feature modeling tools as an alternative to the variability DSL that was developed in this work. And with this we end the talk. More details can be found in the paper, particularly for the case study and its results. We also provide the artifacts used in the case study in this public repository that we see here, the URL. Feel free to contact me or any of the other members of the team if you have any questions. Thank you for your time and attention, and enjoy GPCE and the Splash conference. See you.